And how far away? Oh, that's nice to know. She's been allowed today. All right. So we were doing fractions before. So let's continue on with that. We're in chapter 2 still. We will get started on chapter 3, and I hope we'll get through chapter 3 today. Chapter 3 is not too bad. There's less going on than the fraction chapter. Let me put it that way. So fractions continue. We're going to talk about dividing fractions. And we're going to hit fractions to decimals and back again. So, let's start off with a quick thing on mixed numbers, just to make sure that, like, sometimes when you're dividing fractions, you'll start with a mixed number. So let's do one real quick right now. Let's say I have 2 1/7, and I'm going to divide it by 4 2/3. Alternatively, you might see it like this. They might write it as a fraction, where, because division is a fraction, they might write it like this.
You're losing your pedals.
Yeah, it looks like it. I may have to not use green today. We'll find out. It does look like
Yeah,
that.
killed it.
Okay. So to do division of fractions, you always want just a fraction. So remember, to make a fraction improper, we're going to take this number, we're going to multiply it by that. So I'm going to say 2 times 7, and then I'm going to add it to the top. So I'll do 2 times 7, and I'll have plus 1. Where this stems from is 2 1/7 is really 2 plus 1/7. And we talked about adding fractions together. I need to get a common denominator. And a common denominator would be 7. So if I want this to have a 7 on it, I need to multiply this number by 7/7. So 2 is like a 1. So now I've got 2 times 7/7 plus 1/7. And that's how I get over to that. Because when the bottom is the same, we can add them. You don't need to walk through all that if you're comfortable going from here to here or straight to here. 2 times 7 is 14 plus 1 is 15. I'm going to do the same thing with the 4 2/3. Except I don't want to use the 7, I want to use its denominator, which is a 3. So I'm going to multiply that by 3/3. That gives me 3 times 4 plus 2/3. And that means instead of dividing by 4 2/3, I'm going to divide by 3 times 4 is 12 plus 2 is 14. 14/3. Damn, this would have been good the way it is. But I gotta turn it to division and just ruin it. Here, shit cancels out of its multiplication, but it's not going to when I divide. So we talked about doing that on Monday. Switching, going to division, dividing by fractions is a bitch. So we don't do it. Do it. What we do is instead multiply by the reciprocal. And that may be a word you're not familiar with, or maybe you've heard before and don't know what it means in the math sense. What it means in the math sense is just flip the number upside down. So instead of doing 15 divided by 7, or 15 over 7 divided by 14 over 3, I'm gonna leave the 15 over 7 alone, because that's not what I'm dividing by. I'm gonna change the division to multiplication. And I'm gonna flip that bad boy. This is gonna be 3 over 14. And ideally, you should check to see if something reduces first. We talked about factoring numbers before. 15 is 3 times 5. That's over 7. And 14 is 7 times 2. And we can only cancel stuff that's on the bottom, one's on the bottom and one's on the top. On the top, I just have 3s and 5s. On the bottom, I just have 7s and 2s. So they don't have a number in common on both sides of the fence. So nothing cancels out. So we just have, remember when we multiply fractions, we multiply the denominator separately than the numerator or the top. And if you throw this in a calculator, this is 45. And if you throw that in a calculator, I believe that's 98. And we know it doesn't reduce because we checked the smaller numbers already. Maybe you guys want to give it a try. Let's see, how many? We'll just pick ones that we won't have the mixed number yet. Let's say 5 divided by 20 over 49. Nope, 49 over 20. Got to do the same problem I had in the last one. Make sure everybody's walking in the right direction. Hopefully you took the 20 over 49. Or 49 over 20 and you flipped it over and made it 20 over 49. So the division turns to multiplication and the second fraction flips over. Okay. So if you got to this point, rather than multiplying straight across right away, you try to break the numbers down and see what cancels out. So what do we have here that might cancel out? 18 is 3 times 6. And 6 is 3 times 2. And on the bottom I have 5. 20 is 4 times 5. And then the 4 is 2 times 2. So I can break down the 20 into that. 49 is 7 over 7. Not a lot canceled out here. Just the 5. So the bottom will just be the 7 times 7, which is 49. To make this go a little quicker than using a calculator, I have 3 times 3 times 2 times 2 times 2 on top. 3 times 3 is 9. 2 times 2 is 8. So I've got 9 times 8 on top. And I can do that without a calculator. That's 1 times 2. So you should get 72. We already showed nothing else got smaller here because we had everything as a prime number. And that's it. That's all there is to that one. And now, there might be some areas in fields that you use fractions. A lot of the times you're gonna switch to decimals. To be in real life, realistically. So why don't we take a look at how we would turn these numbers into decimals? So how do I get to decimals? I'm going to use the 45/98 as an example. That was the first number I did. That's not pleasant, it's not pretty. And I will do the 72/49. (45/98) is 45 divided by 98. 72/49 is 72 divided by 49. Now, and we looked at doing this to go from improper fractions to mixed numbers. The way that works is the bottom number divides into the top number. You can do this part with a calculator. There's no reason in real life you would stop to go slowly with this. So if you write it in this form, switch the fraction to this form to help you remember. This is literally what you put in the calculator. And I didn't bring my good calculator with me, so I'm stuck using the phone one that I think is slower. We don't know where all the buttons are. 45 divided by 98. On this one, my phone is giving me 0.45918367335. And on the left one, I'm getting 1.469387755. Now, in general, who wants to have this many decimal places? This is useful. That many decimal places is useful for anything. Yes, there are careers where it's useful, like astronaut, rocket scientists. Having that many decimals, that level of precision is important. If we were working with money, we would only need 2 decimal places because we only go up to cents, right? So let's talk about, I don't know, have we done rounding? I think we've done rounding here.
Yes, we talked about it.
We talked about it. Let's round these to 3 decimal places real quick. Just to bring it back up again. So what I'm looking at for each of these is these 3 decimal places. And when I do, I look to the number to the right and see if I'm going to round up or not. Remember, if the number to the right, if it's 5 or larger, we round up. In neither case is it larger than 1,000 or larger than 5. So 5 or larger. So this one becomes 0.459. And this one will become 1.469.
That's the method that I use to get to this list.
Right. Now, you may not draw the line underneath it and do the arrow pointing like that, but that's just for lecture purposes so people can see what I'm saying. All right, so going from a fraction to a decimal is pretty easy, right? Just pull out the calculator, divide. Going the other way, unless you have the right calculator, isn't It's not too bad. Some calculators do it, but if your calculator doesn't, how do I get this to a fraction again? Now that I've rounded, I'm not gonna be able to go back to the old one. I will not get the 45 over 98 again. I will not get 72 over 49 because I chopped some of that shit off. I can't get it back if I just had these. So a way to get these back to fractions. Or like maybe not back to fractions, but just decimals to fractions in the first place. If you never knew this was 45 over 98, I just gave you 0.459. How can you turn this into a fraction? Count the decimal places. Put that many zeros behind a 1. And make it the bottom of a fraction. In both of these cases, there were 3 decimal places. So I'm going to put 3 zeros behind a 1. And I'm going to make that the bottom of the fraction. Then just put the number on top without the decimal. So 0.459 just becomes 459. And 1.469 becomes 1469 on top. Or I can leave the 1 separate and just put the 469 on top. This goes the other way. So sometimes going to a decimal is quicker without the calculator. Because all I did was, here I counted the decimal places. If I want to go the other direction, if you have a fraction with just a 1 followed by zeros on bottom, count the zeros. Take the number on top and move the decimal point left that many times. If you don't see a decimal point, the decimal point's at the end. Like if I have $1, I'm not going to say 1 point. I'm just going to say 1. So if there is no decimal point, it's at the end. So let's do the one we had. Let's do the 459, 100. We know what that answer is. I should be able to get back the 0.459 that I started with. So I have 3 zeros here. And it's like the decimal point is right here since I don't see it. I'll put it right there. And I'm going to move the decimal point left 1 time, 2 times, 3 times. It's going to go there. So this will turn into 0.459. And then I don't need the bottom. Yeah.
Do you also have to put the 0 or do you know? Like behind the decimal? Like you put one.
No, don't put the 0 behind the decimal. Because I didn't have a 0 right here.
I mean,
If you had a 0 right there.
But I meant it from just to like help out.
Oh, yeah, it's a good idea. That's a pro tip. Thanks for bringing it up.
But I think in the assignments that if you don't put a 0 in the front, I think it marks over.
Really? Well, that's good to know. Maybe I should do some of the homework assignments, not just assign them. I assume they wouldn't be stupid and allow you to give both answers.
Yeah, that or I was just wrong on that question.
It could be that. I like it. The other one we had was the 1469 over 1,000. So I've got 1469. And the decimal point starts at the end. There's again 3 zeros. I move it left 3 times. And I get the 1.469. The mixed number version is very similar. We also wrote this as 1 and 469 over 100 or 1,000. Remember, this means 1 plus 469 over 1,000. So when I shift that, this becomes 1 plus 0.469. I move the decimal point left 3 times. And then we're adding decimals. So yeah, you could throw it in the calculator, or as long as you know the shit to the left of the decimal adds, and then the shit after the decimal adds. You get 1.469. Let me give you guys just a couple ones to try for yourself. We'll go both directions. We'll do some fractions to decimals and then some decimals to fractions. So do 4 divided by 25 as a decimal. Let's do 1 over 3 as a decimal. And maybe we'll do one that we said where it's at the bottom of the 100 or power of 0. And let's do 35 over 100. And let's do 149 over 10,000. We'll convert those to decimals, and then we'll look at doing decimals to fractions. freedom. Yeah. Say that again? These are fractions to go to decimals on this one and then decimals to fractions on this side. Yeah, those are different questions, not. One's not the answer for the other. Hopefully you get, let's see, that should be 0.16. It should be 0.333, and the threes just keep on going. This one doesn't require a calculator if you count the zeros. I got 2 zeros, I will move the decimal point left twice, and I get 0.35. Same thing on this one. I've got 4 zeros. So I'm going to move the decimal point left 4 times. I go left once, twice, 3 times. If I want to go a 4th time, I need to put a 0 in front. So this one becomes 0.0149. That was sneaky shit right there. If you're going the other way, we can count the decimal places. I've got 2 decimal places, so I'm going to have 2 zeros on the bottom, and this becomes 29 on top. I've got 10 plus 0.207. This has got 3 decimal places. So I'm going to put 3 zeros on bottom after the 1. Put the 207 on top and put the 10 there. And here I've got 3 decimal places. So I put 3 zeros on bottom and put 7 on top. You should always check to see if these reduce these fractions. Or simplify by finding the factors and seeing what cancels out. I don't think either one, any of those fractions simplified though. Before I segue to percentages with this, one other topic that I managed to somehow miss is when you have fractions with exponents. Exponents means you write the thing to multiplied by itself that many times. So 2/3 squared is 2/3 times 2/3. And once you remember that the exponents turn into multiplication like this, then we're back to just multiplying fractions. This turns into 2/2, or 2 times 2 over 3 times 3, and I get 4/9. So the fractions don't do anything magical with exponents, just means more multiplication. I did have, if you throw this into a calculator, what do you get? I believe you get 0.4444 and you keep going. Someone check that for me, 4 divided by 9.
Yeah.
Okay, and we had that earlier with the 1/3, with the 0.33333. So when you have a number that just keeps repeating and it won't fucking stop, you can write just it once and put a bar over it. That bar is like, it's like the repetition bar, just keep repeating. That's the uniform way we have agreed to as a species, at least everybody I know. I think it's true in all the other languages as well that use the Arabic numerals. The repetition bar represents repeating numbers. This holds true if it's repeats in a cycle. So if you have 0.123, 123, 123, 123, and it just keeps going like that, the numbers that repeat get put all underneath the repetition bar. How much you'll use that, I don't know, but I think while we're covering decimals, I think I should make you aware of that. You guys ready? Let's do it.
Right.
So, you know what? Let me do this. So it shows up as 2 different videos real quick. Stop. Oops.